Okay, so in this instance, we've been presented with a hydrocarbon. We've been told that its empirical formula is CH and its molar mass is 182 grams per mole. And we've been asked to work out the molecular formula. Okay, so how am I going to approach this? Well, we would need, in order to try and get at the actual molecular formula, which we know is would represent the actual number of atoms of each element present in a given compound. To get from the empirical formula to that, we would need some way to compare the, well, if we could get the molar mass of the empirical formula, we can compare that with the molar mass of the molecular formula and work out a ratio, because we do have the formula for the empirical formula. So this is part of the rationale of how I'm going to approach this. Right, so in this case, what am I going to do? So the first thing I'm going to do is I'm going to actually try and work out, okay, well, how can I get to the molar mass of the empirical formula? Well, we've been given the empirical formula in the question, and we can work out the molar mass of that using the corresponding molar masses of the constituent elements, which we can get from the relative atomic masses of those elements from the periodic table. Although with carbon and hydrogen, given how common they are, you probably already know what the relative atomic masses are. But nonetheless, just to go through a bit of a more systematic process, we've got hydrogen and I guess carbon, and I've got them written here as well. But if you take a look here, we've got 12 and 1, right? And these are effectively our relative atomic masses, but also in the context of this question, they are also our molar masses, right? So MR is what I'm going to use to represent molar mass. The molar mass of carbon is going to be, as you see, it's going to be 12. So that's going to be 12.0. And the MR of hydrogen, right, it's going to be, as you saw, is going to be 1, right? It's going to be 1. So it's going to be 1.0. Right? And so I'm going to use those values to calculate the empirical formula, the molar mass of the empirical formula. And how am I going to do that? Well, I'm going to multiply these molar masses in each case by the constituent, the coefficient associated with each of the elements. So the coefficients are not written here, but we can infer what they are based on the formula. So because in this case they're both 1, right? So we're not going to see a 1 written there, but we know that the carbon is going to have effectively it's 1, right? So so that's going to be 12 times 1. And then I'm going to add this to the same but in the case of the hydrogen, right? So for hydrogen, we've got 1.0 as the molar mass. So 1, and we multiply that by what we see as effectively the associated coefficient for hydrogen, which, given you've just got H there, we can say, okay, well, it's 1, right? The coefficient is 1. And so this is going to give us the molar mass for the empirical formula. So if you work that out, I mean, this is basically, if you look at it, it's just 12 plus 1, right? So it's going to give us 13, right? And so we can say that the MR of CH, right, is equal to 13 grams per mole, okay? Okay, so we've got that, but now we need to work out, well, how does this help us? Right, so what we have is we've got the molar mass of the empirical formula. We've been told in the question the molar mass of the molecular formula. Effectively, all we need to do at this stage is work out, well, what's the relationship between the two in terms of the multiplier, because we're going to have a multiplier here, and we know that they're not the same value, right? So we're going to work out a multiplier. The equation I'm going to use for working out the multiplier, which is just based on the reasoning I've just explained, effectively is going to be that the multiplier is equal to the molar mass of the molecular formula. Which we don't have yet, right? We don't have the molecular formula yet, but we know what the actual molar mass is. We know what the value of the, we know what the molar mass of the molecular formula is, even though we don't know what the molecular formula is yet. But when we divide that by the molar mass of the empirical formula, which we have both, right? We have the empirical formula and we have the molar mass of it, right? But nonetheless, for this we just need the molar masses. That's going to give us our multiplier, and in this case that is effectively 182, right, which you have in our question, divided by 13. Okay, so that's going to equal 182 divided by 13. So if you work that out, you would find that that will give us what our multiplier is going to be. Alright, so if you work that out, what you're going to find is that's going to give you 14, okay? And so therefore our multiplier is equal to effectively 14x. So if you do a 14x, that's effectively the multiplier we need to apply to the empirical formula to get to our molecular formula. And as we know, the empirical formula is CH, right? Just CH. So let's do it step by step. We'll do the carbon and then we'll do the hydrogen, although both are 1, so you know the outcome for each, the coefficient's more or less going to be the same, but we'll do it systematically nonetheless. So for carbon, we're going to have effectively 1, which was the coefficient for carbon, and hydrogen 1 as well, right? But we'll focus on the carbon anyway. We'll focus on the carbon, and that's going to be 1 times 14, right, which is equal to 14. And we can say, okay, based on that, we know that for carbon, for the actual molecular formula, we're going to have C14, okay? And for hydrogen, we've got, as we saw, we've got 1 again, right? So CH, we've got 1 again that's associated with hydrogen in the empirical formula. So that's going to be multiplied by our multiplier, 1 times 14, and that's going to be equal to 14. And so we can say, okay, that's going to give us H14, right? Now, what is actually going to be our product here, right? Our product here, therefore, if we effectively consolidate these values, we're going to get C14, H14, okay? And this is effectively, in this case, our molecular formula, C14, H14, okay? Now, you can, if you want, you can try and verify that. So you can take the similar to what we did with the empirical formula, you can kind of take these values and, you know, do something like, for example, 12 times 14 plus 1 times 14 and see what you get, right? I'm not going to go through the entire process of working that out, but you can effectively work that out, and what you should get is the same as effectively what we were provided in the question. You should get 182 if you do work that out. Anyway, so that is our molecular formula, C14H14. All right.